The test pilot advances throttles at 0900 hours on May 6, 1944. Edmund Allen sits in the cockpit of the Douglas XB-42 Mixmaster as the experimental bomber accelerates down the runway at Santa Monica. The aircraft looks like nothing else flying. Sleek fuselage tapering to pointed nose. Thin wings. No visible propellers. The propellers are there, buried inside the fuselage. Contra-rotating pusher props, driven by two Allison V1710 engines through extension shafts running the length of the aircraft. The configuration eliminates the drag of wing-mounted engines and produces performance approaching early jets. In 30 seconds, the XB-42 will lift off and climb to 15,000 feet, where Allen will push the speed to 410 miles per hour. Faster than any American bomber has ever flown, and faster than many fighters. But the aircraft will never enter production. The Army Air Forces will order 2 prototypes and cancel the program before the second flies, concluding that jet engines are the future and piston-powered bombers, no matter how fast or innovative, are obsolete before completion. The Mixmaster will demonstrate that piston engine technology could reach speeds previously thought impossible, but will simultaneously prove that reaching those speeds did not matter when jets could exceed them while being simpler to design and maintain. The hidden propellers allowed the XB-42 to look like a jet and fly almost as fast, but could not overcome the fundamental truth that jets were actually better, demonstrating that sometimes innovation in existing technology is rendered irrelevant by revolution in new technology, regardless of how well the innovation performs. The Douglas XB-42 Mixmaster was an experimental bomber designed to explore high-speed performance through unconventional configuration. The design originated in 1943 when Douglas Aircraft Company engineers examined how to achieve maximum speed from piston engine bombers. The conventional approach, twin engines mounted on wings with tractor propellers, created substantial drag. The engine nacelles disrupted airflow over the wings. The propeller discs created drag. Cooling air for the engines required scoops and ducts that added more drag. Every element reduced maximum speed. Douglas engineers proposed radical alternative. Bury the engines inside the fuselage. Drive contra-rotating pusher propellers at the tail through extension shafts. And create clean aerodynamic shape without external protrusions. The concept eliminated nacelle drag, reduced propeller interference with wings, and allowed streamlined fuselage design. The theoretical performance gains were substantial. The Army Air Forces approved development of 2 prototypes in June 1943 under designation XB-42. The project was experimental. Even if successful, production was uncertain. But the potential for 400-mile-per-hour bomber performance justified investment in prototypes to test the concepts. The specifications reflected the pursuit of speed. Wingspan, 70 feet 6 inches. Length, 53 feet 2 inches. Height, 20 feet 8 inches. Wing area, 555 square feet. Empty weight, 20,400 pounds. Maximum gross weight, 35,200 pounds. The aircraft was medium bomber size, comparable to B-25 Mitchell or B-26 Marauder. Power plant, 2 Allison V1710-12. Cylinder liquid-cooled engines, each producing 1,800 horsepower. The engines were mounted side by side in the fuselage, positioned near the center of gravity. Long extension shafts, approximately 20 feet each, connected the engines to the propeller gearbox at the tail. The shafts were precisely machined, carefully balanced, and enclosed in fairings to minimize vibration and stress. The propellers were contra-rotating. 2 3-blade propellers mounted on concentric shafts rotating in opposite directions. The forward propeller rotated one direction. The rear propeller rotated the opposite direction. This configuration canceled torque, eliminating the asymmetric thrust that affected conventional twin-engine aircraft if one engine failed. It also improved efficiency by recovering energy from the slipstream of the forward propeller. Maximum speed, 410 miles per hour at 23,000 feet. This was extraordinary performance for 1944 piston-powered bomber. The B-29 Superfortress, the most advanced American bomber in service, achieved maximum speed of 357 miles per hour. The British Mosquito, the fastest operational bomber of the era, reached 408 miles per hour. The XB-42 matched the Mosquito while carrying heavier bomb load. Cruise speed, 290 miles per hour. Range, 1,850 miles with 4,000-pound bomb load. Service ceiling, 29,400 feet. The performance across all parameters was exceptional. The aircraft could fly faster, climb higher, and operate more efficiently than conventional bombers. Bomb load, 8,000 pounds maximum in internal bomb bay. This was less than heavy bombers but comparable to medium bombers. The bomb bay was located in the fuselage center section between the engines. The configuration allowed substantial payload while maintaining the clean external lines. Crew, 3. Pilot and co-pilot sat in tandem under bubble canopy that provided excellent visibility. Bombardier occupied prone position in the nose. The crew arrangement was unconventional but efficient, minimizing frontal area and maintaining streamlined shape. Armament. Defensive armament in prototype was minimal. 2.50 caliber machine guns in remotely controlled tail turret. Production versions would have added more guns, but the prototype focused on performance testing rather than combat capability. The first flight occurred on May 6, 1944, from Mines Field. Later Los Angeles International Airport. Test pilot Edmund Allen, chief test pilot for Douglas, conducted the flight. Allen was experienced pilot, veteran of testing numerous Douglas aircraft including the A-20 Havoc and A-26 Invader. He understood experimental aircraft and the risks of first flights. The takeoff was smooth. The aircraft accelerated rapidly, lifted off at approximately 100 miles per hour, and climbed away cleanly. Allen reported the controls were responsive, the engines ran smoothly, and the unusual propeller configuration created no unexpected vibrations or handling problems. The flight lasted approximately 30 minutes with Allen conducting basic handling tests, climbs, turns, speed runs at various altitudes. Subsequent test flights explored the performance envelope. The XB-42 achieved its design speed of 410 miles per hour in level flight at 23,000 feet. The handling at high speed was reported as stable and controllable. The acceleration was impressive. The aircraft could accelerate from cruise to maximum speed rapidly, suggesting potential for boom and zoom tactics against enemy fighters. But problems emerged during testing. The extension shafts, while precisely engineered, were prone to vibration at certain engine speeds. The vibrations could be managed by avoiding specific RPM ranges, but this complicated engine operation and limited tactical flexibility. The cooling system for the buried engines was complex, requiring careful monitoring to prevent overheating. The contra-rotating propellers required precise synchronization. If synchronization failed, the resulting vibration could damage the aircraft. More fundamentally, jet engine development was advancing rapidly. The first American jet aircraft, the Bell P-59 Era Comet, had flown in October 1942. By mid-1944, the Lockheed P-80 Shooting Star was under development with projected performance exceeding the XB-42. Maximum speed over 500 miles per hour, with simpler engines and less maintenance complexity. The strategic calculus shifted. The XB-42 offered incremental improvement over conventional piston bombers. Jets offered revolutionary improvement. Resources invested in piston engine bombers, even fast ones, would be resources not available for jet development. The Army Air Forces made pragmatic decision. Focus on jets. Cancel piston engine programs that did not have clear production justification. The XB-42 program was effectively terminated in late 1944. The first prototype continued testing through 1945, accumulating data on high-speed flight, propeller performance, and unconventional configurations. The second prototype was completed, but flew limited test program before being grounded. Neither aircraft entered production. The total investment was 2 prototypes and extensive engineering data. Douglas attempted to salvage the program through variants. The XB-42A added turbo superchargers to increase high-altitude performance. The XB-43, a proposed jet-powered version, would have replaced the piston engines with turbojets while retaining the basic airframe. Neither variant proceeded beyond preliminary design. The concept had been superseded. The operational concept the XB-42 was designed for became obsolete before the aircraft proved itself. Fast-medium bombers were valuable in 1943 when fighter escort was limited and bomber speed provided defense. By 1945, long-range fighters like the P-51 Mustang could escort bombers throughout missions. Speed was less critical when escorts could engage enemy fighters, and jet bombers promised speeds that rendered even the fastest piston bombers comparatively slow. The technical achievements were substantial regardless of production outcome. Douglas engineers had solved the problem of transmitting 2,000 horsepower through 20-foot extension shafts. They had developed contra-rotating propellers that operated reliably at high speeds. They had created aerodynamic design that achieved 400-mile-per-hour performance without exotic materials or construction. The knowledge gained influenced subsequent designs, even though the XB-42 itself was dead-end. Post-war, the surviving XB-42 prototypes were used briefly for testing before being scrapped. The airframes were not preserved. No complete XB-42 survives today. Only components in storage and photographs documenting the design. The aircraft that represented the pinnacle of piston bomber performance disappeared because it arrived at a moment when piston bombers were becoming irrelevant. The comparison to contemporary designs shows both the XB-42's achievement and its obsolescence. The de Havilland Mosquito achieved similar speeds using conventional twin-engine configuration, but required lightweight wooden construction and relatively small size. The XB-42 achieved similar performance with metal construction and larger airframe, but required complex mechanical systems. The Me-262 jet bomber achieved 540 miles per hour with simpler engines and less mechanical complexity. The progression was clear. Piston engines were reaching their limits while jets were just beginning. The hidden propellers that gave the XB-42 its distinctive appearance and impressive performance were simultaneously its greatest innovation and its fatal limitation. The innovation was real. Contra-rotating pushers driven by buried engines eliminated drag and produced exceptional speed. The limitation was equally real. The mechanical complexity required to achieve that configuration was greater than jet engines that could exceed the performance with simpler systems. The Mixmaster nickname, coined by crews who saw the contra-rotating propellers during maintenance, captured the unusual nature of the design. Like kitchen Mixmaster with dual beaters, the aircraft had two propellers rotating in opposite directions, mixing the air and producing thrust. The name was affectionate but also slightly mocking. The elaborate mechanical solution to achieve high speed seemed overcomplicated compared to emerging jet technology. The legacy of the XB-42 is primarily educational. The aircraft demonstrated that piston engines could achieve performance approaching jets. It proved that unconventional configurations could work if engineering was rigorous. It showed that innovation in existing technology could produce impressive results. But it also demonstrated that impressive results from existing technology do not matter when new technology renders the entire approach obsolete. The jet revolution in aviation was not gradual evolution, but discontinuous jump. Piston engines improved incrementally. More power, better efficiency, higher speeds. But each increment required more complexity and reached diminishing returns. Jets offered fundamentally different approach, simpler mechanically. Capable of speeds piston engines could not match, and with development potential that extended far beyond initial capabilities. The XB-42 was caught on the wrong side of this revolution. It represented the ultimate development of piston bomber technology, achieving performance that would have seemed impossible a decade earlier. But it arrived when jets were proving they could do everything piston engines could do, plus more with less complexity. The timing was unfortunate but inevitable. Every revolutionary technology creates moment when existing technology, no matter how well developed, becomes obsolete. At 0900 hours on May 6, 1944, Edmund Allen lifted off in an aircraft that looked like the future and performed better than anything flying. The XB-42's clean lines, hidden engines, and contra-rotating propellers suggested advanced technology. The 410-mile-per-hour maximum speed confirmed exceptional performance. But the aircraft was actually the past, the final evolution of technology being superseded. The future was jets, simpler and faster, making the Mixmaster's elaborate solutions to piston engine limitations irrelevant before they could be exploited. The Douglas XB-42 Mixmaster, the hidden propeller bomber that reached 400 miles per hour while looking like a jet, demonstrated that innovation's value depends on timing. The aircraft was technically successful. It flew. It achieved design performance. It proved the concepts worked, but it was strategically irrelevant. Jets were a better solution to the same problem. The hidden propellers produced impressive speed through complex engineering when jets produced more speed through revolutionary simplicity. The lesson is that incremental innovation, no matter how clever, cannot compete with revolutionary change. The XB-42 represented pinnacle of piston bomber development. Streamlined aerodynamics, efficient configuration, maximum speed from available engines. But jets represented new paradigm. Fundamentally different propulsion, allowing fundamentally better performance. When paradigms shift, excellence in the old paradigm becomes irrelevance in the new one. The aircraft that looked like a jet proved that looking like the future is not the same as being the future. That achieving 400 miles per hour with pistons mattered less than achieving 500 with jets. And that sometimes the most impressive innovation is the one that demonstrates the technology being innovated upon has reached its limits. The Mixmaster mixed air with hidden propellers to achieve speeds that seemed impossible for piston bombers, while simultaneously proving that piston bombers, regardless of speed, were becoming obsolete in an era when jets were the actual future waiting to replace them.